All right, let's just jump right into one of the most mind-bending ideas in all of cosmology. What if I told you that our entire universe, everything you can see, everything you know, might actually exist inside a black hole? It sounds crazy, I know, but we're going to break it down.
So to even get our heads around this, we have to start by challenging our most basic assumption about the cosmos. We've all been taught the Big Bang was the absolute beginning of everything, right? Well, what if it wasn't? What if it was something more like a cosmic rebound?
And look, I know this sounds like pure science fiction, but it's not just some wild guess. As you can see here, this is a serious hypothesis that physicists are actively exploring today. It's all rooted in the actual mathematics of general relativity. Okay, so to see how this could possibly work, we need to get familiar with two of the most extreme concepts in all of physics, the Big Bang and black holes. And it turns out the key that links these two totally different things is one single baffling idea. And that idea is the singularity. You can think of it as a point of infinite density, where our rule book for the universe, our laws of physics, just completely breaks. And here's the crucial part. We think there's a singularity at the beginning of the Big Bang, and also at the center of every black hole. Now here's where they differ, and this is really important. The Big Bang singularity is a moment in the past. It's the when we all came from. A black hole singularity, though, is a place in the future. See, once you cross its event horizon, every possible path you can take leads to the center. The singularity isn't just some location. It literally becomes your inevitable destiny, a moment in your future that there's no escaping. The connection gets even weirder, though, when we introduce the black hole's theoretical twin, the white hole. This is the idea that really builds the bridge between a black hole and our entire universe. Think about it like this for a second. Most of the fundamental laws of physics work just as well going forwards in time as they do backwards. It's a key principle. So, what happens if we take Einstein's equations that describe a black hole, an object that only ever pulls things in, and just run the whole thing in reverse? Well, you get a white hole. It's the perfect mirror image. It's a totally bizarre but mathematically valid solution to Einstein's equations. It's a region of spacetime that you literally can't enter. Instead, matter and energy just violently erupt out of it.
And this is where it all clicks. A singularity in the past spewing out all the matter and energy of a universe. Doesn't that sound almost exactly like how we describe the Big Bang? It really does. And this powerful analogy is what's driving this entire theory.
But there's a pretty big problem. Physicists really do not like infinities. A singularity is basically a giant red flag in our equations where our theories fall apart. So what if something actually prevents that infinite collapse from ever happening in the first place?
Yeah, that whole concept of infinity is basically a giant signpost in the math that just says, hey, your theory's broken right here. So a lot of physicists believe that right on the very edge of that infinity, some new force, some kind of new physics must kick in to stop the crush and prevent a true singularity from ever forming.
And this leads us to the big bounce model. Here's how it would go down. First, matter collapses inside the black hole. But instead of crushing down to infinity, it hits a kind of wall, a point of maximum, but still finite density. Then, bam, a super powerful repulsive force from the quantum world kicks in. It's like this ultimate pressure that pushes back against gravity. This pushback forces all that matter to rebound in a massive explosion, a big bounce. And if you're inside it, this bounce would look exactly like a Big Bang, creating a whole new universe.
And you know, this might not have been a one-time thing. As this simulation here suggests, a universe could actually go through a whole series of collapses and bounces. And with each bounce, quantum effects could make the universe bigger and more massive until one final colossal bounce creates a universe like ours, one that just keeps on expanding. So look, this is a fantastic story, right? But for scientists, it's not enough to be a good story. It has to make predictions that we can actually go out and test. So how could we possibly find any evidence for a universe that might have existed before our own?
That is the million-dollar question, isn't it? And the answer is pretty incredible. A big bounce wouldn't be a perfectly clean break. It would have left behind specific, observable fingerprints on our own cosmos that we can actually search for today.
So scientists are hunting for several key clues, these fingerprints left over from the bounce. For instance, maybe some relics from the previous universe, like ancient black holes, actually survived the transition. We might even find a sort of rotation echo, a preferred spin direction in galaxies that reflects the spin of the parent black hole. But the biggest clues of all? They're hidden in the afterglow of the Big Bang itself.
And this could be the smoking gun.
This evidence comes from the cosmic microwave background, that faint glow left over from the Big Bang. Now, on this chart, that colored area shows the range of predictions made by the Big Bounce theory. And that little black cross, that's the actual data we've collected from the Planck satellite. It falls smack dab inside the predicted range. For a theory this wild, that is a stunningly good match.
But wait, it gets even better. The James Webb Space Telescope has been finding these massive, well-formed galaxies so early in the universe's history that they're really hard to explain with the standard Big Bang model. But if supermassive black holes existed as relics before the bounce, they could have acted as seeds, helping these galaxies form way faster than we thought was possible.
So, if the evidence keeps piling up and this theory turns out to be right, well, the implications are just staggering. It would force us to completely rethink our place in the cosmos.
I mean, just follow the logic here for a second. If our universe is the interior of a black hole that formed in some parent universe, then what's happening inside the trillions of black holes that exist in our universe?
The conclusion is pretty inescapable. Every single black hole could be the seed for a new baby universe. This paints this incredible picture of reality as an infinite chain of universes, nested one inside the other like Russian dolls, just stretching on forever and ever.
You know, this idea beautifully explains our own origins as just a natural physical process. But it still leaves us with one final profound question. If our universe and countless others are just links in an infinite cosmic chain, what or who created the very first one? Now that's a mystery that might just be beyond what science can ever answer.